Well, here we go for extra credit number 4 in Perkins Math 201. Some of these are going to be what we've been doing recently, and some are a little bit of review, but it's all good because we've got a midterm coming up, so it's all going to be worthwhile. So with this one, I would use the division algorithm where you say take 0.08 and divide it into 2.36. And for this one, I need to move the decimal place over by 2 in order to change this into a whole number. So I need to do the same here, move the decimal place by 2. Or if I rewrite it, that means it's 236 that's getting divided by 8. Okay, then 8 won't divide into 2, but 8 will divide into 23. Let's see, it would go... If I put a 3 here, that would be 24, which is too much. So it's a 2. So multiply, this is 16, and then subtract, and it leaves a 7. Carry down the 6. And now how many times will 8 divide into 76? Well, let me see. 8 times 8 would be 64. So that's a possibility, but maybe 8 times 9 would be 72. I think that's it, 9. So 9, and then multiply here would be 72, so the remainder is 4. So I could write the answer as 29 and 4/8. But then this needs to be reduced, so divide by 4 and divide by 4. So it's going to be 29 and divide by 4 here, it's going to leave a 1. Divide by 4 here, it's going to leave a 2. Now the only thing is the original problem had decimals, so the answer should have decimals. And the decimal form for a half is a 0.5. So finally, 29.5. And then for the next one, this is a little bit of review. So one way to do this is you can do the whole number minus the whole number, and then the fraction minus the fraction, and then combine those two at the end. Or another way to do it is change this to an improper fraction. So this would be 15 plus 1 is 16, so it's 16/3. This would be 10 plus 4 is 14, so this is 14/5, and then we're subtracting. And now I need a common denominator, and with these two, I can use the common denominator of 15. This one, I would need to multiply by 5 on the top and the bottom. This one, to change it to a 15, I need to multiply by 3 on the top and the bottom. So for this one, it would be 16 times 5. 5 times 6 is 30. And then 5 times 1, that's 5. With 3 more is 8. So this one is going to be 80/15 minus. And then over here, I need to figure out 14 times 3. So 3 times 4 is 12. And then this would be 3 with 1 more is 4. So 42/15. All right, then subtract 80 minus 42. So 80 minus 42, need to borrow. This is going to be 10 minus 2 is 8. And then 7 minus 4 is 3. So it's going to be 38/15. And then the original problem has mixed numbers, so my answer should have mixed numbers. So a 15 will divide into a 38. Well, I know 15 times 2 is 30, so it will go 2 times. And then if 15 times 2 is 30, it leaves a remainder of 8. So 2 and 8/15. And then the last thing I have to do is check and see, could this be reduced? Well, the only numbers that will divide into an 8 would be, for example, a 2 and a 4, but neither of those will divide into 15. That means number 2 is done. On to number 3. So for this, the first thing I need to do is distribute. So take this -2 and multiply it with this, multiply it with this, and multiply it with this. So this 6, I'll do in the next step. There's nothing I can do with this 6 right now. I need to do multiplication first. So the 6 will stay there. And then there will be -10x. And then this times this will be +14y. And then this times this, -16. Okay, on to the next. Distributing, multiply through or distribute by -3 on all of these. So on this one, it would be a negative times negative is +6x. -3 times y is going to be -3y. And then -3 times -5 is +15. And then what I need to do is combine like terms. And I'm going to go in alphabetical order. I'm going to do the x's first. So there's 2 terms that have x. And when you combine these two, it's going to be a -10x plus a 6x. That's -4x. Next, combine the y terms. So that would be this one and this one. So that's a +14y, and then -3 would be +11y. And then last for the numbers, so that would be a 6 minus 16. So that leaves -10. And then add 15. So these two together make +5. And then just circle it, it's done. On to number 4, a little word problem. So this coffee machine costs, so here's the original cost. It's on sale for 20% off. So 20% means we're using the decimal 0.20 because the word percent literally means per 100. So if you have 20 per 100 and then you change this to a decimal, it's going to be 0.20. So we need to take 3849 and find 20% of that, so multiply by 0.20. The first part's going to be easy because it's 0 times everything, so that's just going to be 0, 0, 0, 0. Next, 2. Well, I'm multiplying by a 20, so actually I need to put a 0 as a placeholder right here. And then 2 times this would be 0. 2 times this would be 8. 2 times this would be 16. And then 2 times this would be 6. One more would be 7. And then add these guys. So this is 0, 0, 8, 6, 7. Now for the decimal place. So this has 1, 2 decimal places, and this has 1, 2 decimal places. So in total, that's 4 decimal places. So move this over by 1, 2, 3, 4 decimal places. And that means that this is the decimal answer, or in other words, this is the discount. $7.68 discount. So finally, to finish, take the original price, which was, okay, I put a 0 right here, and I had a 9 right there. I'm sorry, but I'm not going to redo this whole video just for that. So here's the original problem. The coffee machine cost $38.49. Somebody had put the wrong label. Sorry about that. Anyway, Just pretend that was a 0, continue, everything's the same. So it's a $7.68 discount. So take $38.40 and we need to subtract $7.68. Well, then I need to borrow. So this is going to be 10 minus 8 is 2. Also, I need to borrow again. So this will be 13 minus 6 is 7. Carry down the decimal point. Here, 7 minus 7 will be 0. And then 3 minus nothing. So finally, the coffee maker cost $30.72. And then just buy it in Oregon so you don't have to pay sales tax. So this person makes $17.40 an hour. And for 1 week, he made a total of this. And then how many hours did the person work? So if you take this number, the total, and divide by the hourly rate, then you'll figure out how many hours it is. So really the question is just asking, take 556.80 and divide by 17.40. Well, when you have a decimal and there's a 0 at the end, it actually does not contribute anything to the problem. So actually I could rewrite this one as 556.8 divided by, and I could do the same thing on this one and just use 17.4. That'll simplify things a little bit. And then divide, so 17.4 divided into 556.8. And I want this to be a whole number, so I'm going to have to move the decimal over by 1, which means I'll have to move this decimal over by 1. So finally, when we get down to the math, it is 5568 that's getting divided by 174. Now, to be honest with you, when I look at 174 dividing into 5,568, I don't automatically think, oh yeah, that probably goes 7 times. I don't know. But, well, for one thing, if I did do a 7, I put a 7 right here, I would have 7 times this, which means the number would start with 7, which is too big. So you could use sort of a guess and check method like that. You could also, if this is how many hours somebody worked per week, they probably worked 20, 30, or 40 hours. So I'm going to guess that the answer is approximately 30 hours. So I could then put a 3 right here and then try it. So 174 times 3, this would be a 12. Next would be a 21 with 1 is 22. And then this would be 3, 4, 5. So it would be 522. And that's actually close to the 556 that's right here, but it didn't go over, so I think that is correct. Then subtract. So this is going to be 0, this is going to be 3, this is going to be 4, and then carry down the 8. Okay, next. So if I put, I'm thinking I should put a 3 right here, because if I put a 3, then 3 times this 1 would give me that 3. The only thing is if I put a 3, it would be 3 times 7, and I would have to carry, so I better check. If I put 174 times 3, this would be 12. Oh, wait a second, I just did that. 174 times 3 is actually 522, that's too big. Okay, so how about 174 times 2? This would be an 8. This would be a 14. This would be 2 with, oh my gosh, it's 348. Yes, yes. So it's a 2. And then when you multiply by 2, it's 348. Perfect. Remainder is 0. That means we're done. That means the person worked 32 hours. And by the way, with word problems at the end, you should put what the units are, so you don't have to write out a whole sentence. The person probably worked 32 hours, etc. But don't just put the number 32. You should say what the units are. 32 hours. And then square roots. So on Thursday, March 10th, which is when I'm making this is when we're covering square roots. By the time you see this, we will have done this in class. So I would start here. With the square root of a fraction, you can take the square root of the top and take the square root of the bottom. So you're basically breaking it into two simpler problems. I'm going to do the same thing over here. The 2 stays there, and then take the square root of the top and take the square root of the bottom. And then the square root of 9 is 3. So it's going to be 6 times 3 over, and then the bottom, the square root of 100 is 10. Then for this one, the 2 stays there. It's waiting until I do these square roots. The square root of 1 is 1, and the square root of 25 is 5. And then this is multiplication, so I could rewrite this as a fraction and say that's 6 over 1 times 3 over 10. This one I could write as 2 over 1 times 1 over 5. And then in here, multiply, and this would be 18. So this first one is 18 tenths minus, this one would be 2 fifths. And then I would need to get a common denominator, subtract them, and then reduce. Or I could do the reducing now. And I'm going to go ahead and do the reducing now. Both of these numbers can be divided by 2. So divide by 2 and divide by 2. That will make the numbers smaller from this point on. So this would be 9 on top and 5 on bottom. And then once they did that, it turns out they already have a common denominator, so I can just subtract them. 9 minus 2 would be 7 fifths. And if you look at these numbers, which actually became these numbers, they are improper fractions, so I don't have to change this to a mixed number. If I wanted to, just for extra fun, it would look like this. 5 divides into 7 one time with the remainder of 2. So this would be acceptable, but this is 7 fifths is how you should write the answer. Next up, number 7 is the combination of decimals and fractions. So there's parentheses, so I need to work inside the parentheses first, get a common denominator, which is going to be an 8. So this one I could multiply by 2 on the top and the bottom. I'm going to deal with this 1.8 later. Working inside the parentheses, this would be 2/8 plus 1/8. And then inside the parentheses, when you add those two, it is 3/8. And now what happens is we have the two different systems. One is decimals and one is fractions. So I need to either change this to be a fraction or change this to be a decimal. Personally, I prefer fractions. So I'm going to use fractions. So over here on the scratch paper, I'm going to take 1.8, and that means that it is 1 and 8 tenths, because this is in the tenths place. So it's 1 and 8 tenths. And then for the number 1, I could rewrite it as 10 over 10, because 10 divided by 10 equals 1. And that way they have a common denominator. I can now add them, and it's going to be 18 tenths. And before I take that, and replace it over here at the 1.8, I'm still going to go one more step with this and reduce it. So divide by 2 and divide by 2. So divide by 2 and divide by 2. On top is going to be 9, on bottom, so 9/5. So 9/5 is the same as 1.8. So replace the first one, 1.8, with a 9/5, and then times, and I could either put parentheses or I could just say times the 3/8. And then what I would do at this point is look and see if there's any reducing. With a 5 and a 3, do they have anything in common? No. With an 8 and a 9, do they have anything in common? No. So just multiply on the top would be 27. Multiply on the bottom is 40. And then this is already reduced because I checked to see if it could be reduced over here and it can't. That means this can't be reduced. And then another one that combines decimals and fractions. So this one is saying take 7.2 and divide by 2. So, you know what? The thing is, if I divide this by 2, it's going to leave me a decimal. And then I'm going to have to change this to a decimal. Maybe? Yeah, let's just use decimals. The last one we used fractions, we'll use decimals. So, for this one, divide 2 into 7.2. Carry the decimal point. So, a 2 into a 7 will go 3 times. When you multiply, this is 6. And then subtract, so that's a 1. Carry down the 2. And then a 2 divides into a 12 6 times. And when you multiply, it turns out there's no remainder. So this one turns out to be a 3.6. Then what about the 3/8? So it literally means take 8 and divide it into 3. And an 8 won't divide into a 3. That means we need to use decimals. So I'll put a decimal point and then a 0 placeholder. And then an 8 divided into a 30 would go 3 times. So this would be 24. You subtract and we get a 6. And then repeat the process. An 8 will not divide into a 6, so I need another 0 right here. Carry down the 0. And then an 8 into 60. Well, 8 times 7 is 56. So 8 times 7 is 56, and then subtract, it leaves a 4. And then we've got just one more step. Put one more 0, carry it down, and then an 8 will divide into a 40 evenly. It'll go 5 times. So remainder is 0. So this one's decimal is 0.375. So now we just need to subtract those two. So 3.6 minus, and then line up the decimal, 0.375. Right here where there's blanks, I can put zeros as placeholders, and then I need to borrow. So from this, I can borrow, make this a 5, this will then be a 10. And then from the 10, I can borrow and make this last place a 10. So this one is 10 minus 5. This one is 9 minus 7 is 2. Right here is 5 minus 3 is 2. And then 3 minus 0 is 3. So 3.225. And then I look back at the original problem and it has both fractions and decimals. That means I get a choice. I can leave my answer as either decimals or fractions. And I'm going to leave it as a decimal. And then using the Pythagorean Theorem. So the Pythagorean Theorem says this side squared plus this side squared equals this side squared. So x squared plus 12 squared equals the largest side squared. And then x squared plus 12 times 12 is 144. And on this side, 13 times 13 is equal to 169. And then we're going to do 2 steps of algebra. In order to find out what x equals, well, you could either just guess numbers and say, I think it's 1. Plug in a 1, square it, see if it works. It's not. Then try a 2. Plug in a 2 for x, square it, add it to 144, see if it equals 169. I don't think it's going to work. Then you try a 3, and by now you get tired of doing the guess and check, so instead we use a couple steps of algebra. One is, you are allowed to subtract the same number from both sides of an equation. So I'm going to subtract 144 from both sides. It's going to cancel that. So on the left side, it's going to leave just x squared. On this side, I do need to subtract, so this is going to end with a 5. And then this is going to be 6 minus 4, so that's a 2. And then 1 minus 1 is 0. So it's basically saying what number do you square and you get the answer 25. Well, that number needs to be 5 because 5 squared is 25. And then for the last one, estimate as a decimal how much is the square root of 200. So one way you could do it is you could say, well, 200. So let me see. If I put 10 squared, that's equal to 100. No, it's got to be bigger than that. And I could put 11 squared is 121. No, it's bigger than that. 12 squared is 144. No, it's bigger than that. 13 squared is 169. No, it's bigger than that. 14 squared is... Anybody know 14 squared? Yeah, I don't know. So 14 times 14. So 4 times 4 is 16, and then this would be 4 with one more is a 5, and then put a placeholder. 1 times 4 is a 4, 1 times 1. So this would be a 6, this would be a 9, and a 1. 196. And then that's very close to 200. So then I could say, all right, so the answer has to be a little bit bigger than 14, and only a little bit bigger than 14, because this almost made it to the 200. So then I would say, I think the answer is approximately, and for approximately you put a little wavy equals, not to say it equals, but it's approximately equal to 14.1. And then you could check your answer. So with square roots, you can always check your answer by taking your answer and square it and see what it equals. See if it's close to 200. So 14.1 times 14.1. First of all, multiply by a 1. Multiply by a 1 and multiply by a 1. Then put a placeholder. Next, multiply by a 4. Multiply by a 4 would be 16, and then 4 times this is a 4, and one more is a 5, and then put 2 placeholders, and now multiply by 1, multiply by 1, and multiply by 1. Okay, now add these. So this is going to be a 1, this is going to be a 8, this is going to be 6, 7, 8, and then this is going to be a 9, and then a 1. And this has 2 decimal places, so move this over. And so if I put the answer 14.1, when you square it, it's actually 198. Sorry, my computer was falling asleep. I'm glad you're not, though. So it would be 198. And If we were trying to be extremely accurate, like if this was pre-calculus class, I would say you need to guess again and get even closer. But 198.81, that's pretty close to 200, so I'm sticking with my answer, 14.1.